Hey everybody, this is Gregory from Dapp University, and today we're talking about smart contracts. We're going to look at the code of a smart contract, and I will walk you through creating a real estate contract where we will model the sale of a house title and effectively sell a house on the blockchain. Now this video is part 2 in a mini-series where we're talking about smart contracts. The first video in this series, part 1, is a conceptual overview of what a smart contract is and what a smart contract does. So if you missed that, I'll put a link to that in this video and down in the description below. Also, I might do some more videos in this series if you all are interested. So if you are, please leave a comment and be sure to subscribe to the channel so that you can see more videos when they come out. Okay, so in part 1, I talked about how the blockchain allows us to create the internet of value, and we can safely model, store, and transfer value between accounts and smart contracts. We can transfer things besides just cryptocurrency, and that's exactly what we'll be doing in our tutorial today. We're going to write a smart contract that models the sale of our house, so our contract will know that the owner of the title has transferred from one account to another. Now this video will be an introduction to smart contract code. If you'd like a more in-depth and advanced explanation, you can check out my tutorial where I walk you through building your first decentralized application from the ground up. So if you're interested, I can post a link to that here and in the description down below. So before we start coding our smart contract, you should know that contracts are written in the Solidity programming language. And you can see that we're on solidity.readthedocs.io to get an overview of what Solidity is and how it works. So you can check this out in your spare time if you'd like. But for now, I'll just mention that Solidity is a contract-oriented language, which means that contracts are the basic building blocks of our decentralized applications, or dApps. And they're kind of like objects and an object-oriented system. Contracts are the place where we encapsulate all of the behavior and all of the data that live in our application. And if we look at some code examples, you can see that Solidity is a language that looks a lot like JavaScript. So you can kind of just look at the language, and it should look somewhat familiar if you have a programming background, and if you've ever worked with web technologies. You've probably seen, function declarations like this. These control structures should look pretty familiar. Yeah, just basic stuff. And the next thing I wanted to show you is Remix, and this is where we will actually write the code to our smart contract. Now, Remix is a browser-based IDE put out by Ethereum, and it makes it really easy to get started. It allows you to create and publish and debug all your smart contracts without having to configure any kind of development environment locally on your computer. Now, if you'd like to see how to set up your development environment locally for smart contract development, then you can check out my tutorial where I walk you through building a full decentralized application. And you can see the link to that down in the description below. So Remix is pretty nice. We've got this area where we can see our open file. I've gone ahead and created a new file here on the side called realestate.sol. And you can add a new file of your own if you'd like by clicking this plus button and creating a new file. I'm going to cancel for now since I've already done that. And you might have seen a file here already when you open Remix for the first time. You can just delete that file or clear it out. So down here we have a log of a transaction log that we'll see when we start interacting with our smart contract, and some controls here on the side to compile our smart contract, some commands that we'll use to run our smart contract, and some settings and debugger and things like that. And we'll get more into these parts as the video goes on. So let's dive into writing the code of our smart contract. Now, we're writing a real estate smart contract where we're going to allow an account to sell their house to another account. And we'll do this by making the first account the seller, and the seller will publish the title to their house to our smart contract. And a buyer will purchase the title by telling our smart contract that they want to buy the house, and the smart contract will be in charge of taking the money or Ethereum from the buyer and sending it to the seller. And it'll also be in charge of updating the fact that the buyer is now the buyer of this title. And if the title has a buyer, then we'll know that the house has been sold, and the account that bought the title is now the owner of the house. So let's see what that code looks like. First, we have to declare the version of Solidity that we are using when we code our smart contract. You can actually see that we have a Solidity version specified in our query variables in the URL up here. So we'll just stick with that, 0.4.19. So in our code, we do that like this. We say pragma Solidity. We use a caret, 0.4.19. And we will end each line with a semicolon. Now the next thing that we need to do is declare our contract. This is kind of like creating a class in an object-oriented language. We say contract, and we give it a name. We'll say real estate, to be the same as our file name. And we'll open that and close it with curly braces. And you can see that Remix closed that for us, which is pretty nice. Now that we're inside of our contract, the first thing that we'll do is declare a constructor or an initializer. And what this will do is it's a function that will get run once and only once, and it's called whenever our contract is compiled and deployed to the blockchain. Now we define a constructor by declaring a function, and we'll name our function the exact same name as the contract. And this is how Solidity knows that this is the constructor function, because it's going to look for a function with the same name as the contract. So inside of our constructor, what I want to do is set all of the data for our contract. So we basically want to define who is the seller. We need to know what is the street address of the house that we're selling. What is the title? And what is the price? And we'll do all those things inside here. So let's go through those one by one. First of all, we'll go from the bottom up. We'll say the price is 99 Ether. Now in Solidity, we store currency values not as Ethereum, but we store them in something called Wei. And Wei is basically the smallest unit of Ethereum cryptocurrency. You can't subdivide Ethereum any smaller than 1 unit of Wei. So if we were going to represent 99 Ether, we would want to represent that with a much larger value of Wei, which I'm just going to paste in here because I can't remember the conversion off the top of my head. So 99 Ether would look like this. So this is how we declare the price. And we're setting the price here as a variable. And this variable is not just going to be a local variable inside of our constructor, but this is going to be a state variable. And we'll do that like this. So I declare a state variable for the price first by giving it the type that I'm going to be setting as. In this case, it's an unsigned integer. See, I'm going to do a little completion that Remix gives us. So an unsigned integer of price. And by doing this, I'm able to set the value of the price state variable in our constructor here. And our contract knows that it needs to keep track of the price. Now, the important thing to know about state variables inside our contract is that these state variables are actually written to disk on the blockchain. They're not just written in memory to our smart contract. Our contract actually stores the value of these things. Now the next thing that I'm going to do is take this state variable and I'm going to declare it public. And when I declare it public, Solidity is going to give us a getter function so that I can read the value of this smart contract externally, and we'll see that here in a minute. And the next thing that I'm going to do is add the title. So we'll do the title just like the price. Oops. We'll create a state variable. And I'm just going to use an encrypted string here to represent the title to our house. So in order to do that, we'll need to set a state variable. This time we will call it string. And we're not going to make this public because we don't want the title to our house to be accessible externally from the contract. We only want to know about the title within the contract. We don't want anyone else to be able to read this value. And next we will set an address. Let's call this 350 5th Avenue, New York, NY. This is actually the address to the Empire State Building. So I guess that is the property that we're going to be buying and selling in this tutorial. And we'll add that here. We're going to make this public as well because this is data that we want to read externally. And the last thing we want to know is who is the seller. We'll do that with a state variable as well. So how would I know who the seller is in this case? Well, the seller will be represented by an account address. And accounts on the blockchain have addresses. These addresses are unique identifiers that we'll see over here on the side whenever we interact with the smart contract when we're done writing it. So for now, we want the seller of the contract to be the account who published it. There's going to be a little bit of magic that happens underneath the hood. We're going to get the address of the account that publishes our contract with some function metadata that's going to be passed into this constructor whenever it's published. And we'll get that with msg.sender. And I explained this a little more in depth in my other tutorial about how to build your first decentralized application. You can check out that for a more in-depth explanation on how this metadata works with Solidity. So I also want to store that state variable. In order to do that, I'll create one of an address type. So great. We have our real estate contract with a constructor, and we have a way to store who the seller is, the street address of the house, the title, and the price. So let's see, we got some warnings over here. I'm going to, no visibility. I'm going to ignore these for now. Let's go ahead and run our smart contract. Now I'm going to go to run, and as far as the environment goes, I'm going to click a JavaScript virtual machine. When I do that, this will give us 5 accounts for free. And if you notice, I said a minute ago, these are kind of what the accounts look like. They're just these strings that are unique identifiers for the accounts. And each of these accounts that are preloaded in here are going to have 100 fake ether. So let's go ahead and create our real estate contract. We can see our transaction log here, creation of real estate pending, and it was successful. So whenever that happened, I can see that these are the functions that are available to us on our smart contract. And we got those functions because we declared the state variables public. We can see the street address right here. We can see the seller's address, which is the same as the account that published the contract, A733C, here, A733C. And we can see the price. And this is the value also expressed in Way. And if we go back and look at our accounts, we can see that the The value of Ether went down slightly in the account that published the smart contract. That's because writing our code to the blockchain always costs gas, and that's going to come from the account that publishes it. Now that we have a way to store all the data about the house that we want to sell, we want a way to actually buy the house. So in order to do that, we first want to keep track of the buyer, and we'll do that also with a state variable. And this state variable will be of the same type as a seller. It's going to be an address. So we'll have a seller and we'll have a buyer, and each of these will be an address of an account over here that is connected to our JavaScript environment. So how our contract is going to work is that if we have a buyer, then we will consider this house sold. So we'll always have a seller because that's going to get created whenever we publish our contract. But we won't have a buyer unless someone actually sends Ethereum to our smart contract and purchases the house, and then that will be sent to the seller. So how do we do that? Well, we want to create a buy function or a BiHouse function. So I'm just going to come down here, start that. First, we'll declare a function, and this will be BiHouse. And we want to declare this function payable and also public. Now these are function modifiers, and what they do is payable tells Solidity that this function is able to send Ether, and public just means that it's going to be accessible to the public interface, just like these state variables were. So inside this function, we want to set who the buyer is. And we do that with the same way we did this. We go MSG sender. Now again, this is something that Solidity gives us for free to tell us the address of the account that is sending this transaction. The account that will call this function and send some Ether will be an address, like one of these we see here, and we will set that value of the buyer to that address. And the next thing that we want to do is send Ethereum from the account that is buying the house to the account that is selling the house. And we do that like this. We'll take the seller, which we declare up here, and we will transfer all right, so what happens here? We're taking the seller and we are giving them, this is what we'll use to send money or send Ethereum to this account, transfer some Ethereum amount. Now, just like msg.sender, we have msg.value, which is also some function metadata that Solidity gives us to represent the value that is being sent in this transaction. And again, this is going to be a value in way, just like this. All right, so we have a way for the buyer to be set whenever we buy the house. We'll do that as the account that sent this transaction, and we have a way to transfer Ethereum cryptocurrency from the buyer to the seller. Now that's all well and good, but we want to add some safeguards to our smart contract. We want to add some require statements, and these are just going to be things that prevent this logic from executing if there are any problems with the transaction. So for example, we want to require that the seller is present, and we do that like this. That just means that we want to check that this address actually exists and that it's not this default value. So we want to ensure that there actually is a seller for the house. We don't want to try to buy a house that has no seller. We'll also require that the buyer is equal to 0x0. So that means that a buyer has not been set yet. That means that we haven't called this part of the function yet. So we've never tried to buy this house twice. That's really what this require statement is checking for. It doesn't want to call this function twice on the same house. We will also require that the sender is not the same account as the seller. We don't want to try to buy our own house. And we also want to require that the amount that we are buying the house for, remember this msg.value, is the same as the price of the house. We don't want to overpay or underpay for the house. We want to make sure that the amount that we're paying for the house is the exact same as the price. And if any of these conditions are not met, then this function will stop execution and these lines will not be run. All right, so those are some safeguards to ensure that our function is working properly. Now let me explain why these are so important. Smart contract code is immutable, and it's supposed to be immutable. It cannot change. That's one of the characteristics of the blockchain. We don't want someone to come in and change this code at any time. Now, that being said, we really want to ensure that our smart contract code is robust, that it has no bugs. So we want to ensure that all of these require statements are there so that there wouldn't be any bugs whenever we call this function. Now, if we were bugs, the only thing we could do is redeploy a new copy of this contract to the blockchain with a new address. And that's exactly what we have to do whenever we recompile this code to pick up our changes that we just made. All right, so what I want to do is create a new copy of this. Like I said, this code is immutable, so anything that we created here is no longer valid because we changed our code. So I have to create a new copy of this, and I'm going to go back to our first account and create. All right, and here's the new copy of our smart contract. So I'm going to clear out the old one, and we'll see that we still have the street address, we have the seller, we have the price, 99 Ether, and we have no buyer yet, which is what we want. So now we have a new function down here called BiHouse, which is exactly what we just created. And we can buy this house by calling this function. Now, normally we could just click these to call these functions since they're readers, but this buy function will require us to send value from one account to another. So we need to select the account that we're sending value from, and we will then be able to call it. So we do that like this. First of all, we want to select the account that we want to buy the house with. Now we don't want to choose the first one because the first address is the address of the account that published this contract to the local blockchain, and that's the same as the seller. And we stipulated that the seller cannot be the buyer, so we don't want to do that. We want to click a different account. Now we selected that account, we want to select the amount that we want to buy the house for. And instead of typing out this really long number here in way, let's change the denomination to Ether. We'll say 99 Ether. And that'll kind of prove to you that 99 Ether is equal to this much way right here. Now that I've got those values filled out, we have an account that we want the buyer to be, and we have the Ethereum amount that we want to buy the house for. Let's buy the house. All right, you can see this transaction log over here. Our transaction went through. And I can know that it went through because I can click this buyer function again and see that that value changes. It is updated to the value of this account right here. C160C, and this is also C160C. We can see that the amount of Ethereum in this account went down by 99 Ether plus a little bit more, and the extra amount was just the gas price that it costs to send this transaction on the Ethereum blockchain. And we can also see that the amount of Ethereum in the first account, the seller's account, went up by 99 Ethereum. All right, so let's try to trip some of these require statements that we coded in our smart contract. Let's go to a different account and try to buy the house again. We'll do 99 Ether. And we don't want this to happen because it's already been sold. All right, you can see that in the transaction logs, revert, the transaction has been reverted to the initial state. And since we tried to use a different account to buy the house after it's already been sold, yeah, we triggered this right here. We can also try to buy the house with the seller's account, and we can also try to buy it for a different price. So we can do that by republishing our contract. We'll clear that out, go back to the first account, and we'll create this again. You can see we have no buyer. Let's go to this account right here. Well, no, let's go back to this. So this is the account that deployed the contract to the blockchain, and it's also the seller. So let's try to buy the house with the seller's account, buy house. You can also see that this transaction was reverted. It doesn't work because we did not allow it to in our code. All right, so let's try to buy the house for a different amount than what's listed. We can say, let's just say 10 Ether. We want to try to basically steal the house with a smaller amount. Let's try. All right, transaction was reverted. Didn't work. All right, there you have it. So there's the introduction to how the code of a smart contract works. And we could do a lot more with this. You know, we could buy and sell multiple houses rather than just buying and selling one house like this. We could actually, lock in earnest money whenever we buy a house and lock that earnest money in for a set amount of time. We could add a timer to our smart contract to release those funds to either the buyer or the seller, depending on whether, an inspection passed or something like that. And we could also do some sort of complex transfer of ownership where we model the title some other way than this string. We could add a set of conditions and all kinds of things. And we could also do something like auctioning a house. We could add a timer for that and allow other accounts to bid on the house and, win the title and the inspection based on the same set of conditions. So you can see that there's a lot more we could do. And this is really just a simple introduction. So yeah, I hope you all found that helpful as an introduction to the code of smart contracts and also the Remix development environment. Again, I've got another video where I'll walk you through in-depth development of smart contracts and a full decentralized application step-by-step. You can check that out by clicking the link in the description below. And if you guys want to see more videos on developing decentralized applications on the Ethereum network, be sure to subscribe to the channel. And until then, thanks for watching Dapp University.